Hey everyone, and welcome back to the channel once again. And in this video we will be discussing a very famous custom hook problem in React, which is asked in most of front-end development as well as React developer interviews. So make sure you watch till the end, and also like the video and comment in the below comment section, which actually encourages me and pushes me to make such more informative videos. In this video we will not only be learning about a custom hook which is named useThrottle, we will also be discussing what is throttling. Throttling is basically a concept in JavaScript which is used in most of the development, which can be either web development or app development. So throttling is basically a concept, and how it is used we will be diving deep into it, and also we will be coding and exploring many things in this video. So make sure you like this video, and before that, you know it, let's start the intro. Yeah, so welcome to the computer screen. This is nothing but this is just a React playground where you can actually play with some React. Basically, this is nothing but you can also call it a sandbox. Okay, before starting, let's see what Google has to say about throttling, right? Let's Google. Sorry for the mistake. Cool. Okay, I found a very direct answer to what is throttling. Throttling is nothing but it is just a technique which is used to limit the rate at which a function is called. A function is called, we need to limit the rate. Whenever you call a function, it executes directly, right? We don't want that. We want it to limit the rate in the sense what? We need to call it after some intervals, like only in 1 minute the function could we could call the function, and after another minute we can call the function, and after the third minute we can call the function. This is what is throttling. Okay, so let's understand with an example over here. I actually have a button, and this button can make an API call to the server. Okay, this is a server, and I want to make an API call through this button. For example, a user comes in and tries to click this button one time. So what will happen? API call will be made. The very first time he clicks the button, the API call will be made. The second time he clicks the button, again another API call will be made. What if he continues? We have, like, you also might have experienced that in case you're not getting the response very fast, what do? You try to click the button very constantly, right? Repeatedly you try to click the button. So what if a user clicks it n number of times or 100 times? How many API calls will be made? 100 API calls will be made. So we don't want that. It is a very expensive thing to make an API call to the server, and this API call can actually freeze your browser. Hence what we do is we perform throttling in this case. So I hope you must have understood this, that API calls are basically expensive, hence it can freeze your browser. And not to make it happen, actually this is an optimization technique. Not to make it happen, what we do is we use throttling. Let's take example that you need to throttle your API calls in 500 milliseconds, right? So for example, it's 0 millisecond, then 500 millisecond, then comes 1000 milliseconds, then comes 1500 milliseconds, right? For example, a user clicks the button, a API call is made. In this interval 0 to 500 millisecond, no matter how many times he clicks the button will have no effect. Basically this button will not make any API calls. The moment it reaches 500 millisecond, it will make an API call, and till the time it doesn't reach 1000 millisecond, it won't make any API call, no matter how many times the user clicks the button in this interval. Right, in this particular interval, no matter how many times the user clicks the button, he won't be able to make any API call. The button basically is active, but behind the scene, imagine it as inactive. Again, from here to here, if he makes an API call at this position, he can only make another API call at this position. In this time interval, the button is again inactive behind the scenes. But yes, you can see the button getting clicked, it seems that the button is still performing well. So it doesn't actually becomes inactive in UI experience, but yes, behind the scene it is inactive. So this is what is nothing but throttling. And how you can implement this? Basically, this can be implemented using the SetTimeout functionality which is being provided in JavaScript and a bit of logic, obviously. Let's get into the algorithm, how we can implement it. Alright, so let's understand what is throttling. Obviously, as this is a custom hook, what I'll do is I'll just list down what all things which we will be needing in order to code this. The first thing is we need to actually take the function, right, which needs to be throttled. Clicking the button is basically a function, right? In this case, clicking the button, right? We will not be taking obviously the button example, we'll be taking another example. The another thing what we need is the delay. These two things are nothing but inputs. The second thing is the output. What we need as output is nothing but the throttled value. In this case, what is the throttled value? Nothing. It's just the function in itself. The function which we are taking as an input, we are returning it, but we are just returning it in a interval after some time, not as soon as the user clicks the button, right? The third thing actually is nothing but the algorithm. The algorithm is we need to calculate what is the current time. So we need to calculate the current time. Next, what we need the last execution time. Last execution time. Initially this will be now. Now is nothing but initial last execution time, right? The last execution time will be now initially, and the current time also is now only. But as we are moving forward, this last execution time will get changed because the last executed will be updated as soon as the throttling is performed. The very next thing is nothing but we need to check that if the time elapsed is greater than equal to delay or not. If it is greater than equal to delay, then only we will, what we'll do, we will set the value again, or we will return the value, right? Or we will basically return the function, not the value, the function, right? If and only if the time elapsed is greater than delay is nothing but again an input which we already discussed, then we will return the function which we have already taken. Fifth is nothing but update the last execution. That's all. And also you need to take care of this delay again, like, so yeah, again, when the button is clicked or anything that is being throttled is executed, it should currently return the function just after the delay. So if the delay is in 500 milliseconds and you have a button in here, if this button is clicked at 0 millisecond, we need to make sure the next click the button should be active is at 500 millisecond. Once the 500 millisecond is clicked and it is active, the next click should be active at 1000 millisecond. The next should be active at 1500 millisecond. This is how the throttling is actually done. So you have the entire algorithm over here, and we will just be using exactly the same thing. Just you need to build up your logic. So let's move into the code and let's discuss how we can actually implement it. So you can see that I actually have a React sandbox in here. And what I'll do is, you can see there is a web view. Actually, this is nothing but the output of whatever code I write. So I'll just change the style. I'm not liking the transparent. I'll just change it to white. Let's see. Yeah, exactly. Fine. As expected. Alright. So I don't need this console log or anything. Apart from that, I also don't need this props, so I'll be removing this. And what I need is, I'll just rename this to useThrottle, right? And okay, so first what I'll do is I'll just create a useState. Before that, I just have to import it. I mean, just have to create the state variable, right? useState. Perfect. Const. So basically what I'm trying to implement is, actually I want to resize my window, and using throttling I will be giving it some delay. Like there will be a delay in resizing event. I will be showing before throttling how it looks and after throttling how it looks. So before that, I'll just make the state variables so that we actually have use state. The x is nothing but the width, which is initially 0, and y is again the height, which is again initially 0. And what I'll do is I'll just change this thing to size, which is x. Basically, as this is an object, like I have used, you can see the use state is nothing, this is just an object, and as we already know, use state returns two things. The first one is the current value, and the another one is the function which actually helps to update this value, which is returning and re-render, right? So what we'll do is size.x, and y is nothing but size.y. Perfect. So you can see in the output window that size is being rendered. We'll just separate it using this. Okay, now what we need to do is we need to trigger this function, right? So we need to create a function which is handling the size event. Handle size, basically this is nothing but it's just a JavaScript function which actually set size to whatever the window height width it is, right? So in this case, set size, as we initially creating this as an object, so set size is also an object which will take window dot inner width, inner width, and y will be window dot inner height. Perfect. So this is going to handle, this is a function which is going to trigger the another function which is set size. Now how do we use this handle size? For that we need to create a event listener, and in that event listener this handle size will be called. So we need to deal with, as we are handling the window size, window is nothing but it is again a side effect. We need to deal with side effect, hence we need what? We need use effect. Use effect, and then what we'll do is we'll call use effect in it. We know that use effect actually takes a callback function in it, and the next one is dependency array. In this case, the dependency array is nothing but just the size. And in this, what we will do is window dot add event listener. The event listener is basically resize, size at e, and then what we'll do is we'll call handle size as the callback function. Now the most important thing, as we are adding up a event listener, we need to also remove the event listener. How we will remove the event listener? We'll actually create a cleanup function. Cleanup function is nothing but when you have a return function, when you return actually a function in it, inside the use effect, I mean, you actually are making a cleanup function, and in this will window dot remove event listener, exactly the same thing, resize, comma, handle size. Perfect. Okay, I hope this should work now. Let's trigger this. Yeah, you can see that it's very fast. It's very fast. Like, for example, I'm just resizing it to this. It's already 1510, the x, I mean. Okay, the what's that? It's width, right? Inner width. Yeah, width is 1510, and as soon as I come to this, it's 803. Now imagine, what if it's not only just a number, it was actually making some API calls. Like, if I would have pulled this one to this one, it's 1400 and 1472, and if I actually shrink the size, it's 1021. So 1472 minus 1021, the number, that much number of API calls it would have made, right? If this was the handle size function, if it would have been a function which actually makes an API call, it would have made that much amount of API calls and could have frozen my browser. I couldn't have used this app anymore. I should have opened a new window, right? This is not a good practice again. For example, I reduce it, it's again 732, a lot of API calls made, and this could have actually be a performance issue, and that's again a very very big problem. So we need to throttle this, right? We need to perform something that actually creates a delay, not making such API calls, but making a very limited amount of API calls, or making a limited amount of function calls. So let's do that. What I'll do is I'll just create a new JSX file, which is useThrottle. Right? Okay. So as usual, we need to import useState, useState, useEffect. Okay. From I'll explain what is this. Don't worry. Why I'm importing all these things, I'll be explaining. And as we already have seen, what is React? What is this? This is nothing but it is just a normal JavaScript function. React is nothing but React is what? React is just a library, right? And we actually have a normal JavaScript function in itself. And this normal JavaScript function is responsible for all this HTML rendering, everything, right? So even custom hooks, what are hooks? Hooks are nothing but these are just normal JavaScript functions. Normal JavaScript functions with some specific use. So what we'll do is we'll just, obviously we need to export because we need to import it over there. Export const useThrottle is nothing but it is just a function. useThrottle, just an arrow function I'll create, right? Okay, now let's go to the notepad and see. The first thing what we need is we need a function. Do you remember that? We need, these are basically the inputs. What I have discussed over here, we need a function, we need a delay. What is this? These are nothing but just the inputs. Let's do that. Exactly what we were doing in the notepad. Value is nothing but just the function and the delay. And what we are going to return, we are going to return, do you see the fourth step? Not the fourth step, second step. We are going to return the throttled value. That's it. Just return the throttle value. Now comes the actual game plan. So what we need to do is we need to create a state variable. Why we need to create the state variable? The state variable is actually responsible to set the throttle value again and again after the intervals, right? So how we will do it? As we already know, we have useState. useState, initially what it will take the value in it, and then here it will be the throttle value and set throttled value, right? Perfect. In JavaScript you give semicolon, you don't give semicolon, doesn't matter. Yeah, apart from that, let's go to the notepad. The third thing is you need a current time and the last execution time. Let's talk about the current time in a while. First focus on last execution. So as I already mentioned over here, last execution initially will be now, right? So const, and we need to keep a reference to it. So that we know that last executed was that time. Again, when we update, we know that the last execution was done at some time. We need to keep a reference to keep the track. Hence, we need what? We need useRef. useRef is just to create the reference. So last executed will again be now, but inside useRef. Initially, as I already told, it is now. So how you will declare it? Date.now. Perfect. Okay. So after this, we actually have set up all the initial values. Now we can move on to the actual logic. Now, as we are going to deal with what? We are going to deal with SetTimeout. As I already mentioned, you can see over here, this entire thing can be done by SetTimeout. Throttling is we are providing a delay, right? That delay can be done only by the JavaScript internal function, which is SetTimeout, right? So we are going to deal with SetTimeout, hence we need what? useEffect, as SetTimeout is again a side effect. So we know that useEffect take a callback function, and a dependency array. In this case, the dependency array will be delay and the value, whatever the inputs are. Perfect. And inside that, what we'll do is we'll perform the SetTimeout operation, but we'll store the SetTimeout reference into a timer. Why we need to do that, I'll tell you in a while. Like, what I mean is, why do we need this timer? Why do we need this timer and we are storing the SetTimeout reference to the timer? I'll tell you in a while. SetTimeout, and we already know, again, this takes a fallback function and the delay, right? The delay. Perfect. The delay. We need to modify the delay and I'll explain everything. So let's go to the algorithm and let's check. What we need to do, we need to calculate the current time. We need to calculate what? Now we will talk about the current time. We need to calculate the current time. So let's calculate the current time. Let now, I'll just reference it to now. Let now is nothing but date dot now. This is the current time. Perfect. This is the current time. Apart from that, we need to check what is the time elapsed. You can check the fourth step, if time elapsed. So we need to calculate what is time elapsed. So let time elapsed is equals to now, that is now minus last executed. Make sense? Now minus last executed. For example, let's move on to here. Okay, so for example, now is, I guess it's 3:24 a.m. right, and last executed was 3:22. So if I subtract this 3:22 from 3:24, can I get what is the difference? How much time has been passed? That is 2 minutes. Can I do that? I can do that, right? That's what we are going to do it over here. So time elapsed is nothing but now minus the last executed dot current. Why we are using dot current? We are using dot current because it's useRef. That's the reason we are using dot current, right? So if the time elapsed is greater than equal to delay, right? The moment it passes delay, what we are going to do? We are going to call the state function, use state function, which is set throttle value. So this knows that throttle value is now ready for the return. It knows that the time has already been passed, but it has already been more than the delay. Now we can return the throttle value. And again, if you check this one, we need to, step 5, we need to update the last execution. So how do you do that? Again, let last execution, oh, I'm sorry, it's already been declared, right? Last executed dot current. Always make sure whenever you use useRef, you need to dot current, which is what you need to update it right now, right? Why? Because just now we are returning it, and what is the current time? Current time is the time when we are returning the throttle value, right? When we are returning the function. So that moment we will update the last executed. Now there is a bit difference over here. We need to also subtract it. Date dot now. I'll explain you. Date dot now minus last executed dot current. I'll explain you this one. Don't worry. So we are actually performing these entire set of function in this time interval, like date dot now minus the last executed dot current, which is entirely subtracted to the delay. And now I obviously need a cleanup function because the SetTimeout is again an expensive function. Hence we need timer over here. This is the reason we need timer. So we need to return the cleanup function, return. And how do you clean up? Clear timeout, not interval, timeout to the timer. And yes, we are done. So we just need to call the useThrottle over here. How do you do that? Import useThrottle from /useThrottle. Right? Now, how do you call it? useThrottle basically takes the value, which is nothing but the function, and the delay. So the function is nothing but which function? This function, because it is responsible to set the size, right? If you navigate this one and if you scroll it, you can see how the size is being set. It is this thing. This is actually which is triggering the set size. Hence we need to throttle the handle size. So const throttle is equals to useThrottle. We will basically provide handle size and whatever delay you want. In my case, it's 500 milliseconds. And in place of handle size, everywhere where handle size is used, we will use the throttle, right? We'll be using this throttle. Now let's see. For example, if it's not working. Why is it not working? Let's move to throttle. I'm not sure why this is not working, but oh, I got it. This is the problem. Actually, I should have put the value in here, not the throttle value. You can see, you see this line, there is a throttled value in it. Should have put the value in here, not the throttled value. And now I think this should work. Yeah, you can see there's a delay in it. You can see that, right? So there's a delay in it. So that's how the useThrottle is performed. And what we'll do, we'll understand this line in detail. As I told you, what is this? Delay minus date.now minus last executed. So let's move into this and just create a new one. Okay, so cool. So for example, date.now is nothing but 300 milliseconds, right? And last executed was 100 milliseconds, right? Okay, last executed was at 100 milliseconds and now it's just 300 milliseconds and your delay is 500 milliseconds. So this is the time interval, right? 0 to 500. What if your last executed was here at 100 millisecond and you just have crossed 300 millisecond, right? So you just have crossed 300 millisecond from the 100 millisecond. That means what? You just have completed your 200 milliseconds, right? You just have completed the 200 milliseconds. You also need to complete more 300 milliseconds so that it actually creates the entire 500 milliseconds to perform the throttling again, right? So that's what it means, that always you subtract date.now minus last executed and you check the delay with that, the difference with that, and based on that difference you actually trigger the next throttle. That's what I have done over here. That is, you just subtract it and then you trigger the next throttle. I hope you like this video. If you already have liked this video, please subscribe it if you have not already, and share it with your friends so that they know about the front-end interview question. It will make their life easier. And also many people out there, if you are not yet subscribed, please I recommend you all to subscribe. This actually encourages me to make such videos, to make such informative videos and post it in my YouTube channel. Thank you so much for such love and support, and see you in the next video. Till then, goodbye.